Hi, today we're talking about prisms again, and we're talking about how changing an attribute of one of the dimensions will have an effect on the surface area of our rectangular prism. So we'll be doing some investigating and some problem solving to do so. So let's think about why we would need to find the surface area of a shape anyway. Surface area is when we are covering up the entire outside surface of whatever shape we're looking at. So here's an example of some dog houses and different size dog houses. And we would know that by changing an attribute, whether it's the length, the width, or the height of it, would change maybe the material that we need, the wood to build it, or how much paint we would need to paint it up. So we want to see exactly how it changes. Let's explore. Now remember, an attribute is the length, width, or height of a shape, whatever one of the dimensions are. And in previous lessons, we've talked about scale factor. And scale factor is how does our shape change? Does it get larger? Does it get smaller? And the scale factor is actually the number that we're going to multiply by the dimension by to change the size. So if the scale factor is greater than 1, then our shape will become larger. If our scale factor is less than 1, then our shape will become smaller. We're going to divide. So let's go ahead and use this information to problem solve. Here is our first rectangular prism. You've seen this one before. We've talked about it with volume. This time we're going to talk about it with total surface area. All right, so it says, what is the scale factor? If the scale factor is 2, how does that change our total surface area? And if the scale factor is 1/2, how does that change our total surface area? Well, first we want to figure out what the original value is, what our original surface area would be, okay? Remember, surface area is going to be 2 times your width times your length plus 2 times your length times your height plus 2 times your height and your width. And I have a shorter version that I'm going to use, but this is what you would see on your formula sheet. So you could simply plug this information in, okay? And again, because multiplication is commutative, that means you can multiply your numbers in any order. So whichever one you decide to be your length or your width or your height really doesn't matter, because however you multiply your numbers, you will get the final answer to be the same thing. Okay? So let's go ahead and figure out what the original value is. Okay? So the original value, my shortcut would be if I multiply these two sides together, 2 times 3, I would get 6. Okay, and that would cover up this total area right here. And if I multiplied these two parts together, I would get 3 times 6, which would be 18, and I would add that to my new value. And actually, 3 times 15, that would be this side versus this side. And I'm going to go ahead, we can't see the bottom, but I'm going to go ahead and color. That would be our top value right there. That would be that top face. And then our final face would be our last two numbers that we haven't multiplied together yet. That would be this side right here on the side. And we would need our length times our height. And our height is clear over here, so I'm going to draw a line over to that part. And 6 times 2 is 12. So we have 12. And so then this would be a total of 36 for those 3 faces. But then I would have to multiply it by 2 because I need 2 more. I need another set. I need all 6 sides. So if I multiply the 3 that I have times 2, I would get 6. And so my total surface area for my original shape is 24 feet squared. All right, well, what now if I changed the length by a scale factor of 2? I'm going to say that 6 is my scale factor, my length. So I'm going to change my 6 to multiply it by 2. So 6 times 2 would now become 12. So my new length value is 12. So with a scale factor of 2 for length, here are my new dimensions. So I have my length, or my height, and my width stay the same. So 2 times 3 will stay the same, which is 6. And then 6 is now being multiplied by 12. Actually, let me go ahead and change that color so we can see it in a different color. There we go. So 2 times 3 is 6. I apologize. I'm going to trace over the top of that. And then 3 times 12, which is my new length because I multiplied to a scale factor of 2. So 3 times 12 is now 36. And now I have 12 times 2, which is 24. Okay, so if I did this and I added all of these parts together, I would have that my total surface area for 3 faces is 66. But remember, that's just 3 of them, 3 faces, and I need to multiply it by 2 to get a total of 6 faces. So if I multiply that times 2, my total surface area is 132 feet squared. Okay, so this was my new surface area with a scale factor of 2. That was the original one. Now, if I look, I don't see that if I multiplied 72 times 2, if you multiply 72 times 2, you would get 144. So I did not get that value. So right now, I don't really see a connection between those two values. Now let's see what would happen if I multiplied by a scale factor of 1/2. And let me go ahead and get a new color once again. All right, so by 1/2, if I had 6 before, so my original one was 6, and if I do a scale factor of 1/2, that means my new scale factor is going to be 3. So in this case, I'm going to do 2 times 3, which is 6. So let's see, scale factor of 1/2. And 2 times 3 stays exactly the same, which is 6 plus. And then I'm going to multiply 3 times 3 because I have a new length, and that makes 9. And then my new length times my height still is 3 times 2, which is 6. So I have a total of 21 square feet, and that was for my 3 faces. I want to multiply it by 2 to get 6 faces. And so my total square feet now would be 42 feet squared, and that would be if I have a scale factor of 1/2. And if I take 72 and divide it by 2, do I get 42? Nope, I get 36. So right now I'm seeing that this is how my scale factor affects my total surface area with these values. Go ahead, pause the video, and copy this into your notebook. Okay, we're going to look and see what happens if our height changes by a scale factor of 3. Okay, so we're going to start with our original. All right, and we're going to go around in our circle. So we're going to do 10 times 2, which is 20, and then 2 times 3, which is 6, and 3 times 10, which is 30, and that would give us 56. And that's for our 3 faces. We want to multiply that times 2 to get 6 faces, and we would get that our total surface area is 112 centimeters squared. Very good. All right, well, what would happen then if we change it? So now we have a scale factor of 3 of our, there we go, a scale factor of 3 for our height. And I'm going to call our 3 is going to be our height. So if we multiply it by a scale factor of 3, that makes our new height value to be 9 centimeters. So with a scale factor of 3 for our height, let's go ahead and see what happens. 10 times 2 stays the same, so we still have 20. And 2 times 9 changes, so we now have 18. Plus 9 changes, so 9 times 10 makes 90. So we have 20 plus 18 plus 90, and our scale factor, our total surface area for 3 faces is 128, and we would multiply that times 2 to get our other set of faces to make 6, and we would get 256 centimeters squared for our scale factor of 3 for our total surface area. All right, well, what if our scale factor changes to be 1/3? Let's see how that would change, okay? So a third of 3 is going to be 1. So in this case, we're going to have, so we have a scale factor of 1/3 for our height. So we have 10 times 2 still remains the same at 20 because those are not the dimensions that are changing. Oh, I'm sorry, we're not multiplying, we're adding. Plus 2 times 1, which is simply 2. Let me make this look a little better. It looks like it could be a multiplication. We're actually going to add those two together. So 2 times 1 is 1, and then 1 times 10 is 10. And so now we have 32 as our square feet for 3 of the faces. And again, we're going to multiply that by 2 to get our 6 faces. And we're going to get 64 feet squared if we change the height by 1/3. So hopefully you got those. Very good. All right, let's try another one. Here we have, if we're going to change our width, we're going to change our width by a scale factor of 4. So we want to find the original value. So we're going to multiply our 3 parts together. So 10 times 8 is 80. And then 8 times 5 is 40. And 5 times 10 is 50. So if we added all that together, we would get 170. And again, that's just simply those 3 faces. So we would want to multiply by 2, and we would get a total of 340. They didn't put anything, so we're going to put units squared. And that's our original one. So what happens now if we're going to change it so we get a scale factor of 4 for our width? And we're going to say that our 8 is our width scale factor. So we're going to multiply 8 times 4, and we're going to get 32. So this is going to be quite a large one, won't it? So scale factor of 4 for our width, and let's go ahead and get started. So 10 times 32 is 320 plus 32 times 5. So 32 times 5 is going to be 160. And you notice that that is exactly half of 320 because 5 is half of 10. That's interesting. And then we have 5 times 10, which remains the same at 50. So we have 320 plus 160 plus the 50, and those are, again, that's 530 square units, and we're going to multiply times 2 to get our second set of faces. And so our total surface area now is going to be 1060 units squared, because we don't know what our units are in this case. Okay, well, what happens if our scale factor goes the other direction? If it goes down to be 1/4 for our width. So 1/4 of 8 is 2. So we're going to change 8 to be 2. So our scale factor of 1/4 for our width, our new scale factor, we're going to have 10 times 2, which is 20. That changed. And then we're going to do 2 times 5, which is 10. And then we're going to do 5 times 10, which remains the same at 50. And so we would have that we get 80 as our square units for the scale factor of 1/4, and multiply that times 2 to get our other faces. So we get a total surface area of 160 units squared if we cut it into 1/4. So here we have the 3 different units: our original, our scale factor greater than 1, and our scale factor less than 1. All right, we have then this question: how does the total surface area change when an attribute is changed? Well, in our last one, when we talked about volume changing, we learned that no matter how our scale factor changed, our volume changed the same way. So let's think back and look back at our notes. Did the surface area change the same way that our scale factor changed? Well, indeed, we found, oh, I apologize. Let's click this in a different way. What we find is that when you change an attribute, your length, your width, or your height by a scale factor, the total surface area of the prism does not change in the same way. So it does not change. There's no relationship between your dimensions changing and your total surface area. So this is different from volume. Volume has a direct relationship. It changes the same way, but surface area does not. Go ahead and pause the video and copy this into your notebook. Excellent. Well, now it's your turn, and what I'd like you to do is figure out what the total surface area of this rectangular prism is going to be when you have changing the width by a scale factor of 2 and when you're changing the width by a scale factor of 1/2. What happens to your surface area? Go ahead and do that in your notebook, and we'll talk about it tomorrow with any other questions you might have. Good night.